Now we're given a two-way ANOVA to see if the area... Okay, so this is another thing that I did in my regression class. It did a ANOVA analysis on whether or not the sales of various types of bread were affected by where the bread was on the shelf and how big the shelf was itself. So I'll just write some of this down. So this is a two-way ANOVA with interaction. So you guys should be pretty familiar with this. Let's see. We have one. So this is another real-life example. Someone actually did this ANOVA, and it was just an example in... That's an example in a class. Done by Castle Bakery. I don't know where they are, but they exist. So this is another real-life example. Now, okay, so treatment A was the placement on the shelf. And factor B was the length of the shelf. Okay, so now we're wondering how many treatment levels of A are there? Okay, so this all goes back to the definition. So DFA equals A minus 1, right? It's just a simple, so we get 2 equals A minus 1. That implies that A equals 3. Okay, so we have 3 levels of factor A and 1 plus 1 levels of factor B, so 2. Okay. Now we're at B, so now this wasn't asked, but it's just fresh in your mind. Okay, now we have part B. Why is DFAB 2? Why is that? And that is because DFAB equals A minus 1 times B minus 1 equals 2. So A minus 1 is 2, B minus 1 is 1, so DFAB is 2. So we have 2 degrees of freedom for the interaction. Now part C, this one's a little trickier. We're given that the sample sizes are balanced. What is N total? And how many replications were at each level of A? Okay, now remember, how do we find DF total? DF total equals DFA plus DFB plus DFAB plus DFE. That equals 2 plus 1 plus 2 plus 6 equals 11. So DF total is 11. So remember, DF total equals N minus 1, just like always. We get N equals 11, 12, not 11. N equals 12. So we have 12 things in our sample. Okay? Okay, so now remember, there are 3 treatment levels at A. Okay? So, and each level of A gets an equal amount of the bread types. No. Each level of A gets a, they're each equal in the setup of the experiment. Now remember, A was location on shelf. There were 3 shelf sizes, so there were 3 treatments. No, I'm sorry, not 3 shelf locations. So if there were 12 total sample size, that means at each level they do basically 4 different breads at each level, right? Yeah. So we have at level 1, 2, and 3 we have 4 replications is what it really is called. Okay, and now since this is an F, so we have reps equal rep sub A equals 4. Rep sub A equals 4. Now what about B? So there are 2 levels of B, right? So within each level of A, there are two levels of B, right? And 6 total, yeah. So we have 2 shelf sizes. So within each level of A, we have 2 shelf sizes, so rep of B equals 2. So each replication, the replications of B per treatment are 2. Okay, and there are 3 treatments, so there are 6. So 6 shelves are big and 6 shelves are small. It's a total of 12 shelves, just like we figured out. That one's a little tricky, but I think you're gonna. That's a very reasonable question on a test. Okay, now we are testing for significance. D. Nope, that's a B. Okay, now we're testing for significance of interaction. We just go to this thing. Remember, this is useful for us. And how do we do a test for interaction? We want to see if A, B, equals 0. Alpha beta does not equal ij. And this is for some ij, for some ij. So like alpha beta is 0. Actually, this is alpha beta is 0 for all ij combinations. This is alpha beta is not 0 for at least one of them. Okay. So we want to test if they're. How do we do that? We do F star A B equals 12 over. MSAB over MSE equals 12 over 10.33 equals 1.16. And that's exactly what the table tells us. So that's why it's useful, because it just tells us the f-value. So you don't even need to do the math. You can just go straight to the table. Excellent. Okay, now we're testing for the main effects of A and B. Erase this. Now I'm going to cut right to the chase now. And just know, so we have F star of A, F star of B, it's MSA over MSE, and MSB over MSE. That's just 772 over 10.33, and this is 12 over 10.33 equals 1.16 and 74.74. And given the p-values for A and B, we get a p-value of basically 0 for this one, and a p-value of 0.32 for this one. So we fail to reject for this one. So this is bad. This is no main effect for this one, and there is a main effect for this one because such a high f value, such a low p-value. The p-value is basically 0 for this one. Okay, excellent. So that's the main effect. So what does that tell us? What does that tell us? So that tells us that factor A and B do not interact. So there is no so at different levels of A and B, the effect on sales is not different. So if we're to do an interaction plot, comparing this is sales, and this is factor A, so we have 1, 2, 3, and factor B is the different levels, right? So we would have maybe longer shelf is a higher sales, but so this is factor 1 for B, I'm sorry, level 1 for B and level 2 for B. So if this is level 1, this is a long shelf, this is a short shelf, there may be a difference, there may not be, but we don't really know. We're not given anything. But we know that since there's no interaction, basically, that these lines will be parallel throughout, no matter what level of factor A you're at. Okay, because this parallelism implies non-interaction. Okay, and if we were to switch it and instead do the 2 levels of factor B on the bottom and the 3 levels of factor A, you would have maybe something like this. Okay, these are all parallel, give or take. I mean, like, basically parallel. I can't really draw parallel lines. But regardless of, this could be 2, 1, 3, like where on the shelf it would be. But it doesn't matter because they don't interact. Like, there is a difference, and we don't even know if the difference in the means is different, is significantly different. We'd have to do a Tukey or a Bonferroni interval. What we do know is that since this distance is the same as this one, and this one's the same as that one, so they're all the same, so they don't interact, and that's what an interaction plot of this would look like. And in fact, we know that treatment B doesn't even do anything. Treatment B doesn't even do a single thing. So really, all the power, all the effect on sales is in treatment A. And as it turns out, the higher the bread is on the shelf, the higher the sales are, and that's why that's why supermarkets put the more expensive item on the top shelf, because you're more likely to buy it. You're more likely to see it as a fancier item, which is the truth. They're really lying to you and trying to get the best of you. So watch out. Be a smart consumer.
The Teaching Center, UF's Learning Resource Center.